So I put up my results that I did earlier on in the day. You might get slightly different results, but you should get the same sort of pattern. Everybody? So I got, for my current in the series circuit, I found that it was the same at all those different points, or almost the same at each one of those points. Okay, Daniel? So I found that it was 30 milliamps, so 0.03 amps at each point. Okay, so A, B, C, and D all were the same. They're all 30 milliamps or 0.03 amps. So the conclusion, ammeters measure electric current. Ammeters are always measured in series, always connected in series with components. The black terminal of an ammeter is positioned near the negative and end of the supply, and the red terminal near the positive end of the supply. And in a series circuit, the current is always the same at all points. So no matter where you put that ammeter, the current will be the same anywhere you measure it within a series circuit. Did everybody get that? Or more or less the same? Might be slightly different now. Yeah. Okay. So this is in a series circuit, remember? So in the series circuit, when we were measuring the voltage, hopefully you found the voltage was an easy one, it's just plug and play basically. The results that I got were as follows. So my voltage across lamp L1 was 1.3, voltage across lamp L2 was 1.6, L3 1.5, across L1, L2 and L3 was about 4.5, and across the cell was 4.5. So what is happening there is this voltage, the supply voltage, is the same as the total voltage in the circuit. And these all add up to the supply voltage, or the total voltage. Okay, so if that was 1, that was 2, that was 3, then the total voltage would be 1 plus 2 plus 3, so 6. Okay, that was 10, that was 10, that was 10, the total voltage was 20. So V1 plus V2 plus V3 is equal to the total voltage in a series circuit. So voltmeters measure the potential difference. Voltmeters are always connected in parallel with components. As usual, the black terminal of a voltmeter is positioned near the negative and the red terminal near the positive. In a series circuit, the potential difference of the voltage across a number of components is the sum, or the addition, of the potential differences across the individual components. The sum of the voltages across components in series is equal to the voltages across the battery, or the supply. So the supply voltage is equal to the voltage across each component added together. Remember that voltage or potential difference is a measure of the electrical energy gained by 1 coulomb of charge passing through a supply, or the energy lost by 1 coulomb of charge passing through a load component. There's a transfer of energy in a series circuit, but the law of conservation energy applies. So what I'd like you to do is just to summarize that, write that down in the space just at the end of that page. So in a series circuit, the current is the same at all points. The voltages across each component add up to the supply voltage.
These rules are really important to remember because they will help you way down the line with any electricity you do. Hopefully you're getting to grips with the equipment, remembering some things coming back to you. The next one's slightly more complicated to do. Okay. Is anyone still writing? Am I good to move on? Sorry, leave it up for a little bit longer. Right, okay. So the next one, that was us looking at series circuits. The next two experiments are looking at parallel circuits. So first of all, the current in a parallel circuit, then the voltage in a parallel circuit. The current one is by far the more difficult experiment in these two to do. So just a reminder about how to set up parallel circuits. So back to this. You've just got one cell there. One cell. Then to make a parallel circuit with 3 bulbs in it, remember, you connect one bulb up. Okay. Then connect another bulb in parallel with that. You go from the top of each of that plug to the next one. And then from the top, that the next one again. And then we want 3, so I'm going to do the same thing again. So from the top, there we go. That one. From the top, then to this one. Okay, so we've got 3 in parallel each other. So this is where it gets a little bit complicated because you have lots and lots of wires involved here. I have included photographs again to help you. So the first one, we are connecting in our ammeter into various points. So you'll see we've got point A is just after the cell. So you just want to plug the cell and plug your ammeter in next to it. Okay, so that's the first one, nice and easy. Being in the same plug are relatively easy as well, so you just need to unplug the wire and pop it in. It's the parts D and E that are slightly more complicated. So to get it into D, we have to unplug both of the things that are attached to the bulb there. You see, I've unplugged both of them. And then you put your ammeter in that gap that it is left. And that's to get D. E, you do the same, but for the next one down. Okay, so this one's slightly more complicated. The ammeter one is more difficult, but there are photographs to follow. The voltmeter one, however, is quite nice because all you do with the voltmeter is you get the 2 wires hanging off it and you just